In this example, we're starting off by being given the derivative equation. So what we're being given here is our f prime of x equation, our f prime of x graph. And what they want us to do is they want us to determine how many points of inflection, how many inflection points does the original graph, does f have on this interval they've given us here from -2 to 2. Well, the first thing we got to know on one of these is what is an inflection point? How do I find an inflection point? Well, inflection points occur when two things happen. The first thing that you need to have happen is you need that your second derivative needs to be equal to 0, or your second derivative needs to be undefined. That's the first thing we need. Then the second thing we would be looking for is the fact that it needs to change concavity at that point. So the graph needs to change from going concave up into concave down, or vice versa from concave down into concave up. So wherever that change in concavity happens there, these are what we refer to as inflection points. So notice that when we're talking inflection points are always talking to us about second derivative information. And at this point, you're looking back up here at this first derivative, and you're like, oh man, I'm going to have to do a crazy derivative right now in order to find my second derivative and go through all this process. However, we're lucky enough that this is a calculator allowed section. And so we're not actually going to have to take any derivatives ourselves. What we're going to do is we're going to end up reading the derivative off of our first derivative. Remember that if I start at f prime of x, and I need to get to the second derivative, what I'm really doing here is I am taking the first derivative, right? And so what you can do is read that derivative information off of your first derivative graph. So giving you another example before we dive into this specific one, if my derivative graph does something like this, right, I can read the second derivative off of that. Wherever my graph is headed up and has a positive slope, that's where my second derivative is positive, and that would tell me where the graph is concave up like a cup. Wherever my first derivative is headed down and decreasing, that's where I would have a negative second derivative, and that would tell me where my graph is concave down like a frown. And then wherever it goes horizontal for a second, that's where we would have a 0 second derivative, and that's where we would have our possible inflection points. So when you come to look at your second derivative graph here, what you would do is you're just going to read off where it's going down and up and where it goes horizontal, and that's going to tell you second derivative information. So on a graph like this section would all be negative here. This would all be concave down. Then I hit a 0, and then that's my possible inflection point. And then from there, the graph starts going into the positive. So that's where my original equation is concave up. So what we're going to do on this problem is we're not going to go ahead and find any of this by hand. We're just going to use the graph of our first derivative and read off these pluses and minuses like we were just talking about here. So to do this, what you're going to do, calculator-wise, I'm going to write down the directions first, and then we'll go do it on the calculator. You're going to take your derivative equation that they gave you, and you're going to plug that into y1 on your calculator. From there, the next thing you're going to want to do is graph this. And when you go to graph it, you want to always check your window of your graph. So in this situation, I'm looking at an x interval. This is an x window right here. So I'm going to set my x min and my x max to match this window that they give me here. And I only care about possible inflection points that are happening there. Step 3 of this, after I graph it, is I'm now going to read the first derivative data off my graph, off my calculator. And the cool thing here is because they only want to know how many are happening, we don't actually need to know the actual values. So we can just quickly look at our graph and see where is it going to be changing concavity? Where are we going to run into these types of situations here that I was showing you in that example, where it changes concavity? So I open up my calculator, go into my y equals, and I'm going to type in that equation, x squared and then the sine of x squared. Remember that when you're graphing, on the AP test, it's always going to be in radian mode. So my calculator is already set to radian mode. If you needed to check that, you'd go into the mode button under your calculator, and then down here, you'd want to just change that into radians. Then before I actually graph it, I'm going to hit the window button because I need to adjust that X min and max. So I'm going to go -2. Oops, not 2 there, 2 down here. And I'm going to graph that. My Y min and max I'm just going to leave alone for right now. I might want to adjust them to make my life a little bit easier, but I could probably read off what I need from this. So I hit graph now. And what I'm looking for in this situation is I'm looking for the places where it goes from positive to negative or negative to positive. So looking at this graph here, what you want to do now is read off the pluses and the minuses like we talked about in that earlier example. So starting on the left here, I would be going up. So this whole section here is going to go positive, positive, positive. At the top, I'm going to hit a 0. So that's my inflection points if it goes negative. And sure enough, this goes down. So negative, 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 negative. Boom, I hit another horizontal right here. That's another 0. And then after that, it's going positive. So it changed. It was going down into this, and now it's going up out of there. So then we're going concave up until I hit this 0 over here. And then I'm reading the slope. This is decreasing. This is going down. So that is negative. So what I can see is I have 3 inflection points. Right here where it hits this max, that's where it changed from concave up into concave down. In the middle here, it went concave down into concave up. And then at the far end, it went concave up into concave down. Remember that what you're doing is you are reading off the slope of these graphs. So if we just kind of look at this again, giving my rough sketch of what this thing looks like, I would be reading off plus, plus, plus. These are all going to be where the graph is headed up, and therefore positive. That's going to be concave up. Then I'm going to hit a 0 right here at the top. That's where my possible inflection point is happening. And then on the other side, it's going to go all negative, negative, negative. So that's all concave down into my 0 right here, which would be a possible inflection point if it changes signs. And sure enough, it's going to go plus, plus, plus back into that concave up. And then right here, we're going to have that other inflection point because it changes and now starts going down, down, down. So negative, negative, negative. So what we're looking at on this problem is 3 real inflection points. So the answer would be C. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.